and we started with environmental pollutants and what are the different kinds of pollutants. And then we understood what is the concept of bioaccumulation, biomagnification, bioconcentration with different examples. So with that, we have covered almost the key aspects that was to be derived from Module 1. We will be looking at some case examples of how we can use that information and put that into practice so that we would be able to see that there are some practical applications which are possible and which will make the overall environment and socio-economical aspects improving all the time and in sync with nature. So what is the point? The point is that we have focused on so many different aspects of ecology and environment in this module. Now, how we can relate that in terms of examples or case studies or some success stories. So there are many success stories across the globe. But now what we will be doing, we'll be picking up 3 examples, and I will not be going to the details of all these because it's freely available in the internet. You can find and read for yourself. What I will do, I will just sensitize and inform you about how whatever we have studied, whatever we do understand, we can apply that to practice. It's not that it's all theoretical, but there are success stories around you. So we have 3 examples which very nicely nicely demonstrates ecosystem management. One is this international partnership for the Satayoma initiative. Okay, international partnership for Satayoma initiative. And the other one is Hivre village in our own Maharashtra. Okay. And then Mangroves for the Future initiative. So let us go to these case studies and then understand how they have addressed the challenging environmental issues that confronted these societies. So first one is this National Partnership for Satayoma Initiative. So this is basic. Yes.
Sir, एक विकास
yes, I have admitted him several times. I don't know why he's joining and why he's logging out.
He has network problem. He just
then he has to.
his router is showing no internet. He's joining from mobile data.
That is okay. So that is his problem. So let us let him sort it out. Okay, there are already 129 students. So we cannot hold them for one student who is having some network issues. So we have to respect everyone's time. Okay. So if he's having some issues, let him sort it out. Meanwhile, we'll proceed.
Okay.
Okay. So this is an initiative which is a global effort to realize societies that live in harmony with nature through promoting the maintenance and rebuilding of this socio-ecological production landscapes and seascapes for biodiversity and human well-being. See what happens in simple words when we know that whenever we're extracting something which is very high compared to the rate of addition, what will happen? We are going to run out of that resource, isn't it? So that is what is happening with the modern lifestyle that is being practiced across the globe. So this initiative is a success story which was initiated in 2010, and these are areas where people and the land have a symbiotic relationship. It's not one way. Okay. So each depend on the other to thrive. So that's the whole concept of this initiative. It's not that we just extract the resources for our own benefit and selfishness, but the overall good for the environment and the human being. So this is a partnership which is made up of 258 member organization which is working and allowing societies to live in harmony with nature. So the key goal is natural resources management. Okay, natural resources management in a sustainable manner. Okay, sustainability is the key. Whenever we are extracting, as I told you, something more than what we are replenishing, that's where the problem starts. That's where we end up with too little resource for future generations. So that we are able to meet the present day demand and also preserving something for the future. So that is the key, sustainability. Okay. So here we are following this ecosystem approach, which is core vision to realize. Core vision is to realize societies live in harmony with nature, which is built on positive human-nature relationship. Now, when I say positive human-nature relationship, you should be able to extract a lot of information from this. Now, you yourself think the way we are going about our daily routine, whether it is a positive or negative interaction with the environment. Next example is this Hevre Bazaar in Maharashtra. So this is a village which was highly drought prone, and we all know that how severe water crisis in several districts of Maharashtra, not only in Maharashtra, but in several districts across India as well. There are numerous reports which are coming about the status of groundwater, okay, and surface water resources in India and how little we have. There is one report which says that groundwater may not be available to us after 2030, and in some places it is going to happen much before that as well. So this district was also quite famous, not for a good thing, but for the thing that it was highly drought prone and the socio-economic status of the village was very, very poor, mainly due to the degrading environment. But what these people did, in less than a decade, they were able to turn it completely around and making from very abysmal situation to a highly prosperous village, not only in Maharashtra, but among the whole districts in the country. What it did, it used funds from government schemes to regenerate its natural resources. See, the key is regenerate the natural resources. Watershed management, soil led by strong village bodies. So now it has become a role model in the district, and this village is also famous for Anahjane. So now his Hivre Bazaar is an example for whole country. So that is the kind of attitude what is required. And it is not that whatever you are studying, it will just be left in book. You will be able to see that it can also be applied. Now, what are the things that they did? For example, they conserved the water that was available, they preserved the soil by preventing erosion, and then going for those sort of agricultural practices which was in sync with the nature there. Now, it's a very simple thing. For example, when we lose a well, say I have a well and I can use it. But now if this well water gets contaminated, now I'm forced to buy water. So something which was free to me, what I have done through my practices, I have contaminated the well, and now I'm buying water for 20, 30 rupees minimum for a liter. Now you all are very well informed these days. You can think for yourself. Letting the nature remain as such or investing money to recover something that's contaminated and spending money and energy and resources for getting something that we need on our daily basis. Next example is this mangrove. So mangroves are very interesting vegetation. Okay, so they are growing in areas with low oxygen soil and where there is slow moving waters. So they will not be able to grow on land, and they allow fine sediments to accumulate, and mangroves are very productive ecosystem. I'm sure most of you would have heard 2004 tsunami in India. Did you hear about this? I was doing my PhD. I was doing my PhD in Chennai at that time, 2004 Boxing Day tsunami in Indian Ocean. Surprisingly, there are many districts in Tamil Nadu, in the coastline of Tamil Nadu, where they had this mangrove forest. Those places were literally unaffected because of this huge surge of water. So that's very interesting scientific study. And then a lot of studies occurred following this. And then people were able to realize the benefits of having this mangrove forest, which basically acted as a buffer in stopping the damages that was going to be caused due to this surge of water. And how many of you have seen mangrove forest or even heard about it? Those who have not heard, if you have seen it, very good, Anubhav. But those who have not seen it or heard about it, try Googling. You will be able to see some images. They are very interesting because the roots crops out. So Nikhil, Chetna, Rishabh, they all have seen, very good. So those who are not, I would recommend that it may not be possible for you to visit right now due to the current scenario, but if you are able to go to the internet, you will be able to find lots of information and images and videos also, how these mangrove forests function. They're very interesting case study to do. So one of the objectives of having this part of module is to sensitize you how we can apply whatever we're learning. So mangrove forests grow only in tropical and subtropical conditions because they cannot withstand lower temperatures. There are many mangrove forests which can be recognized by dense tangle of prop roots that makes the trees appear to be standing on stilts above the water. Now the roots, they tangle and allow the trees to handle the daily rise and fall of tides. So that's the preventive mechanism that these mangroves have, which means that most mangroves get flooded at least a few times in a day. So this route also allows slow movement of tidal water, and this allows the sediment to remain close to the root. Now you may be able to understand as we go in this course that sediments are one of the highly nutrient-rich component that is present in water bodies. And this allows buildup of muddy bottom. So mangrove forest stabilize the coastline. Okay, it stabilizes the coastline. It helps in reduction of erosion from storm surges, and it also acts as a buffer from currents, waves, and tides. This is, as I told you, it's a very productive ecosystem, so you can find lots of fishes and other organisms seeking food and shelter. That means mangroves serve as habitat for various varieties of fishes and other organisms. So these are the three case studies which I wanted you to focus. And now this last part of module is understanding a bit of climate change and what is being done across the globe. So basically the idea is to create some awareness amongst you so that you are able to know what is happening on climate front. So what do we mean by climate change? One simple question here. What do we mean by climate change? Anyone can answer this. Anybody who knows anything about climate change, please share. What do we mean by climate change? I just want to test
difference in the weather patterns and temperature around the globe.
Yes, Nikhil. Difference in?
Differences in the weather pattern and temperature shift around the globe.
Temperature shift and weather pattern. Okay, anyone, he has very nicely said. Anyone else would want to expand a bit further?
I actually belong from
The melting of glaciers.
Used to be cold back
yes, Anubhav.
child, but it's very hot now.
Yes, Anubhav, bolo.
I originally belong from Janakpur, Nepal. It's close to the Himalayas, and it used to be very cold when I used to go back when I was 4 or 5. But it's
Okay,
hot in summers now.
very good. That means we are able to feel it, है ना?
Sir, climate is an average of the weather conditions for about a period of 30 to 40 years.
Yes,
So
exactly.
anything which just breaks that average, or it brings a hike or low, brings a rapid change in that average, that proves that points out towards the climate change.
Very good, Ankit. I ask this question almost every year to all the students in this course, and I must just tell you, this is the best answers that I have got today. So that means the level of awareness and understanding is already there. Now let me expand it a little bit more. For example, whenever we say climate change, most of us, I won't say everybody, but most of us believes that it is just global warming. No, it is not global warming only. It can be global cooling, it can be any erratic pattern in weather. And when we say weather, many times we also use this term weather and climate interchangeably, but it is not. Weather is something we feel on daily basis. Climate is over a long period of time, several decades. As Ankit told that, it is on an average which we take for several decades, and whenever there is any deviation from that, either it can be high or it can be low. That's what we say as changing climate. Now, what is the major problem with climate change? We all know the immediate threat is melting of glaciers, of course, sea level rise. And those who come from coastal cities, they would be able to know more about it, because many cities across the globe are already facing this crisis of rising waters. And there are these reports which are saying that many cities may be submerged in next coming decades. That is one aspect. Another aspect is erratic rainfall. Many times, whenever we say rainfall, we talk about averages. Say, for example, I say that Ranchi gets an annual rainfall of 1,500 millimeter. That's very good. But when I say that this year, say I'm saying, for example, the concluded year 2021, I say that Ranchi received, I don't know the exact value, I'm giving you this as an example. Say, I am saying that Ranchi got an annual rainfall of, say, 1,600 ml. Okay, so you will be excited and say, oh, Ranchi got more rainfall than what it should have. But that's not going to give you the exact information. Now, the next question that one should ask is, okay, now tell me, what is the distribution of this rainfall in a calendar year? Say, for example, I said 1,600 mm against an average of 1,500 mm. But what if this rainfall was just confined to some weeks of the year? Now, that is not a healthy scenario. That is not a desirable scenario. That means we should be able to get this rainfall, spread it nicely throughout the rainy season, or whenever the rainfall has been predicted to occur based on historical data. For example, in 2015, Chennai experienced one of the worst floods. The reason being due to heavy rainfall. But now that was just part of the problem, heavy rainfall. But another part of the problem was too much of concrete, not allowing the water to seep through the ground. So that does two things. It does not allow the groundwater to get replenished, and then there is a lot of surface water that flows. And most of the storm network are not designed to carry these surges that happens once in 10 years. That's another aspect. Now, that means the whole weather is changing. Like someone said, that he was experiencing very nice weather when he goes to Himalayas, but now it is not. But similarly, other places, there is this problem of changing weather, changing vegetation. Many species are getting threatened or at risk or getting extinct. Even the whole metabolism of organisms are changing. That means you have understood what is ecological productivity. That means there is direct interference with the productivity of the ecosystem. So once we are interfering with the very functioning of the basic structure which allows life to proceed, that's not a very healthy scenario. Okay, so that is the information I just wanted to know you. Now it is for you to go and read further. There are lots of reports available, and one of the agencies which is leading the climate efforts is known as Ipcc, that is Intergovernmental Panel on Climate Change. There are many countries which meet regularly and they set targets. Main target that we are seeing is related to carbon. We have understood carbon cycle and how it is important. So most of these carbon cycle interferences are causing many of these impacts that we are able to see through changing climate. A lot of research is happening across the globe since we are starting. Don't be in this approach that we are in IT and we are in EEE. That is not for us to do. Believe me, there are much more areas in environment where you can also take up that as either as a career or as a research goal, and it is happening across the globe. Okay. Now, this climate change report, what is they doing? They are basically sensitizing the whole population and policymakers and scientists across the globe by pooling all the data. Different countries are doing a lot of research. Now, how do I know what is France doing, what is Germany doing, what is India doing? So those in France, they may not be able to know what is India doing to confront this problem and tackle this issue. Similarly, we don't know. So what this Ipcc is doing, they are collating all the research that is happening across the globe, and they are pooling that in the form of report so that everybody can have an idea what is happening and what are the goals, what are the approaches. So the major issue started since 1993 when the rate of warming in the oceans doubled, and scientists reported in a study by the UN Intergovernmental Panel on Climate Change that there are melting of two great ice sheets which are blanketing Greenland and West Antarctica. Now this acceleration is increasing all the time. And most of these melting that has happened, it has gone to a stage where we may not be able to recover them. Now rising seas, as I already told you, are threatening low-lying coastal zones, which is close to 680 million people. That is about 10% of the world's population. Now, with water, at least we are able to deal with, we can make water from ocean water. We can make even water that is available in atmosphere. But what about land? Land का हम लोग कुछ कर सकते हैं? Can we make land multiply? No. We need land for industries. We need land for commercial establishment. We need land for housing, and then land is the main source of our food also. So those who are interested, you can look at these terms about UN's food security goals and water security.
By those defects.
So note down these and try to read whenever you get some free time. And then this food, water, energy, nexus. UN is doing a lot of work on this food, water, energy nexus. So the problem is the yield of ocean is going down. Okay, this is already happening. There are very few fish. And then we have this tropical storms, which are getting quite frequent.
What is Nexus?
Nexus means link, basically. Okay, connections. So what is, okay, if there is no water, there will be no food. If there is no energy, there will be no water production also, for example. We need pumps to be operated. Okay, links, basically links. Say, for example, when I say food, water, energy nexus, say, for example, if there is no water, we'll not be able to grow food. If there is no energy, we'll not be able to run, say, for example, water pumps. And if you're not able to get energy in water, we'll not be able to grow food. So that is the link, that is the connection. Now, When we say that these ice sheets that already have given you this example of Greenland and West Antarctica, we have this ocean heat waves which are increasing and threatening. So those who are updated with current affairs, you may be reading about the bleaching of corals in Australia. So the coral reef there in the Great Ocean Barrier, okay. So they are getting threatened now. If they are gone, that means the whole habitat is gone. So related to this, you can also read about ocean acidification. है ना, आप लोगों को तो सिर्फ टेम्परेचर का ही पता है ना, ग्लोबल वार्मिंग के कारण. And then ocean deoxygenation. Please take some time and do some reading on these. I bet you will get some very, very interesting and important information, and it is required.
Also mentioned
That we all understand these things.
We are using
Okay. Already we have understood about the ice melt, so there is a lot of data. I'm not going to elaborate on all that. You can go through that. So the whole report is emphasizing reducing emissions. Many countries, they are going for, say, carbon tax, okay, carbon credits. So there's a lot of pressure on industries and across globes to work on carbon, and the emphasis is to do it quickly. So recently we have IPCC's sixth report is also there. In this slide we are mentioning about assessment report. So there are various assessment reports. There are AR5, AR6. Okay, so this is AR5, where scientists have learned a great deal about the impacts of absorbing atmospheric CO2 on the ocean.
Draw the angle.
So now we also got AR6. Assessment report 6 is also there. You can go through that. It is available now. Now the point is, what do we do with the carbon that is getting released? So there are lots of research, and one of the path-breaking research is from these scientists in Queensland in Australia, which is reporting that ocean is not just part of the problem, but it should be key part of the solution. Because ocean can absorb a lot of carbon that is getting released. So oceans can be used to mitigate the global greenhouse gas emissions. So this study, which was commissioned by a group of 15 leaders, it called the High-Level Panel for Sustainable Ocean Economy. So what it is? So here, these researchers, they highlight 5 ocean-related activities that can slow or reverse the process of warming. These are the major points. One of them is build offshore wind farms and other renewable energy. So what we'll do when we are going for this ocean wind farms, obviously there will be some little
and within this
movement away from fossil fuel usage. Okay, that's a win-win. And then it will be eliminating carbon emission from the shipping industry, number 2. And then we have these restored coastal ecosystem such as mangroves and salt pans. These not only store carbon, but they also provide numerous benefits. As I told you, they act as buffer in preventing the damage due to tropical storms, filtering pollutants, and providing habitat for fish and other wildlife. Now see how a simple misstep from us can damage so many things, and how a similar simple approach can revert it. And then harvest more ocean-based protein sources, because the overall point is understanding the carbon footprint. Whenever we are growing, for example, those who are well aware, they may be able to break down what is the amount of carbon that is produced per kilogram of rice, per kilogram of wheat, per kilogram of fish, per kilogram of any, whether it is animal or plant-based, you would be able to know. So this report is emphasizing store carbon in the ocean floor, which theoretically has high potential for reducing greenhouse gas emission problems. These 5 activities, for example, suggested by these can support the overall goal in as much as reducing 21% of emission reduction. And the target to limit global warming to from earlier it was 2 degrees centigrade, now it is 1.5 degrees Celsius. The earlier models predicted that the temperature will go close to 2 degrees Celsius by this. But then as the studies went on, they said, no, we cannot afford to even have this 2 degrees Celsius as the limit. Now the threshold is set at 1.5 degrees Celsius above the pre-industrial times by the end of the century. So human activity has already increased global temperatures by 1.1 degrees Celsius. And studies suggest these are now on track to blow past mid-century targets needed to achieve 1.5 degrees. That means what these reports are saying that countries are setting this target, say by next 30 years, will be controlling the greenhouse gas emission, which in turn will help to limit the change. But then what we are able to see, the efforts that are being taken, many times they are not found enough to achieve these set goals, okay, that will not allow the temperature to go beyond 2 degrees Celsius or 1.5 degrees Celsius.
I'm not able to check.
This is a very interesting information which is summing up whatever we have discussed so far. So here we are talking about ocean heat content, ocean pH, ocean oxygen. Now, to understand this, you need to follow these symbols, these 4. The blue one is suggesting the changes that are occurring in the cryosphere. White is ocean changes, and the red color circle with this white color arrow in upward showing temperature increase or decrease of pH, temperature, or sea level. Okay, this is for decrease. So, for example, what is decreasing? Snow cover is decreasing, glacier mass is decreasing. What is increasing? Permafrost temperature. Permafrost are permanently frozen areas of land which are covered with ice sheets. Now, if the permafrost temperature is increasing, that means those ices will melt, which would expose the other sheets of ice. Now, what do we have? These are the feedback. So, for water, heat, and CO2. And what is on decline? Arctic ice sheet mass is on decline. Again, what is increasing? Sea level is increasing. Marine heat waves. Now, this marine heat wave, a lot of research is happening because this is what is also influencing the global hydrological cycle. There is serious decline in ocean oxygen. We'll come to this more in module 3, but whenever we have this oxygen that goes less than 4 mg per liter, 4 milligram per liter, many fish species will not be able to survive this drop of dissolved oxygen concentration in the water body.
So can you show the previous slide once again?
Yes.
Okay. Thank you.
So ocean pH. Now what will happen if pH is decreasing? That means more acidic inputs are happening. Now what that will do, that is going to dissolve the minerals and it will increase the leaching, and it will also going to threaten the life that is dependent on ocean waters. And ocean heat current change control water balance. So this illustrates the key components and changes of ocean and cryosphere and their linkages in the Earth system through the global exchange of heat, water, and carbon. So this whole pictogram is able to very nicely sum up what is happening in terms of sea level rise, increasing ocean heat content, marine heat wave, increasing oxygen loss, ocean acidification, and changes in cryosphere due to declining ice, permafrost thawing, decreasing snow cover.
You measure the angle of that one.
So this is more sort of data-driven slide, but this will help you to see what do we have here. Okay, so these are different approaches. These RCPs. These are different approaches for the model. And what we have here is this global mean surface air temperature, global mean surface temperature, and surface pH, dissolved oxygen. So near term is 20, 31 to 50. So this is the mean value, that is average, and this is 5 to 95% range. So what is the range of 0.5 to 1.4? And this is what is the predicted values by 2081 and 2100. You can refer these values and you will be able to understand what we mean. So these are various scenarios, okay, of increasing temperatures.
I am talking about this sequence now. Sequence number 1.
Okay, so this diagram helps us to that what are the options available for risk reduction through adaptation. Those who are interested, you can also climate change and adaptations. So what this adaptations can do, this can reduce the risk factors by addressing what is vulnerable, exposure, and hazard.
If we
Okay.
consider
The examples related to reducing hazards, for example, ecosystem-based measures to reduce coastal flooding, say MFF, the Mangrove Forest for Future. So this is an example. Adaptation, physical, ecological, technological, economic, political, institutional, psychological, and socio-cultural efforts. So these are the limits to adaptation. Now, actions to reduce vulnerability, social protection. Okay, when do we go overusing resources? When we do not have sort of proper awareness, or when we lack resources in a manner that it is going to help.
Then the system.
So if you have the social protection, livelihood diversification, insurance solution, hazard-proof housing and infrastructure, that would reduce vulnerability. And exposure means coastal retreat and resettlement, risk-sensitive land use planning, early warming system, and evacuations. So these are outlined to help us reduce the hazards, exposure, and vulnerability.
Can you get the definition?
This is basically to help you see the extent of ice loss that is happening. So if greenhouse gas emission continue in the manner that it is going on, future sea levels are projected to rise by more than a meter by 2100. And there are also reports that scientists have suggested there can be sudden collapses of ice cliffs.
discussed about the isomer of coordination compound.
This is the image of a national from National Snow and Ice Data Center, which is telling us the extent of sea ice in the Arctic Ocean and how much of it has shrunk. So you can refer these. I have uploaded these slides. You may have seen such images. Unpredictable tropical cyclones, which dumps a lot of rainwater. Even many cities in India are also facing this. This is an example of mangrove forest. You see this, these are the roots which crops up. Now, how dense and how high it can get. So what is this understanding? The understanding is that we have estimated that there will be approximately 1% of 1 degree Celsius of global warming above pre-industrial levels. Now the range is 0.8 to 1.2 degrees centigrade, and it is going to reach 1.5 degrees Celsius by 2030. And if it continues to increase at the current rate, then we are going to see all the problems. So that means when we are talking about these climate-related risks for natural and human systems, so these are higher for global warming of 1.5 degrees Celsius than at present, but lower at 2 degrees centigrade. So the overall target is this. But once we are not able to meet this, then it has sort of to be lowered further. The same thing what I mentioned, the difference between increase of 1.5 degrees Celsius versus 2 degrees Celsius. So we have covered all these. You can go through this slides and you can read more as I've given you many topics. So this concludes the module 1, and we'll start module 2 from next week. And we need to go for quiz. And have you given any quiz for any of the papers so far in this semester?
No, sir.
Not yet, sir.
Okay. So are you familiar with how to give quiz in MS Teams?
No, sir.
No, sir.
Okay.
No, sir.
Then what I will do, I will schedule a mock quiz of 10 marks or 5 marks, okay, just to give you a feel of how it is being done in MS Teams. Okay. I will schedule it for, say, sometime tomorrow evening. So it will be just a small quiz. You will get a link. You just have to answer. Yes, it is mock. Yes, it is mock. Or we can do it. We can do it today evening at say 6 p.m. I will give a quiz.
Yes, sir.
You can just try that how it happens, and then we can go for the real quiz sometime next week. Okay, now answer your roll call.
Sir, what will be the duration and everything for the quiz?
I will brief you all those things. First, let us go through this mock. So you will get this mock for say 10 minutes, okay, or 15 minutes. Say 15 minutes, and then you will be able to feel it how it is being done and see whether you are having any issues.
Sir,
It
can
will
you
be done through MS
make
Teams.
a WhatsApp group for the same?
What's that?
Sir, your profile doesn't give your contact number. So if you could give it to us, we'll make a WhatsApp group and.
It is there in the website. It is there in the website.
Okay.
I have got calls from so many students. Okay, let us go to this roll call. So yes, Jan.
Present, sir.
Absent.
Sir.
Present.
Sir.
Okay.
I want to say something. So yesterday I was
No,
present.
please stop. No, that's all that I have understood. Fine. Now don't interfere because I have to take attendance of 140 students. If someone is having an issue, you can call me afterwards. And if there is any problem with network, mic is an issue, immediately after your name, you just type in the chat box that I was present. That's all. But if you don't do that, mic can have an issue, understand. But if you don't type within, say, next 1 minute or 2 minutes after your name is taken, I'm going to mark absent to your student. Okay, Aruba Tashmi.
Yes, sir.
Ishan Gupta.
Yes, sir.
Okay, Anurag Gupta.
Yes, sir. Present.
Ayush Raj.
Present, sir.
Kumar Sanyam.
Yes, sir.
Shiv Shankar.
Yes, sir.
Mohammed Faizan.
Yes, sir.
Mandravi. Ishwak.
Present, sir.
Vishnu. Rajkumar.
Present, sir.
Abhay Kumar.
Present, sir.
Parijat Milan.
Present, sir.
Rajkumar. Roshan.
Roshan present, sir.
Ronit.
Present, sir.
Piyush.
Present, sir.
Siddharth.
Present, sir.
Praveen,
Present, sir.
Kashif,
Present,
Harsh
sir.
Narayan, Harsh Narayan,
Present, sir.
Yash Padiyar,
Yes, sir.
Pranshu Shekhar,
Present, sir.
Okay, Anshul,
Yes, sir.
Vikas Orav. Okay, he was having network issues. Gyan Ranjan,
Present, sir.
Kumar Harshvardhan,
Yes, sir.
Anas Mishra,
Present, sir.
Prince Aryan,
Yes, sir.
Anubhav Thakur,
Present, sir.
Manshu Raj,
Present, sir.
Aditya Dev,
Present, sir.
Adarsh Ranjan,
Present, sir.
Tarun Agarwal, Akhil Sai,
Present, sir.
Siddharth Saraf,
Present, sir.
Harshit Prandial,
Present, sir.
Amol Kudar,
Present, sir.
Gaurang Dikshit,
Present, sir.
Praveen Dikshit,
Present, sir.
Sudarshan Bhagat,
Present, sir.
Harsh Azad, Aditya Singh,
Present, sir.
Samarth Pratap, Shrestha.
Sir, Samarth present.
Okay, Akarsh Shrestha,
Present, sir.
Nikhil Verma,
Present, sir.
Naveen Raj,
Present, sir.
Prakash, Reshma,
Present, sir.
Yes, sir.
Prakash Maji is present. Okay, Reshma is present.
Prakash Maji present.
Sandil Agarwal, Sandil Agarwal, Aditya Dubey,
Present, sir.
Avi Jain,
Present, sir.
Gaurav Anand,
Present, sir.
Udit Rai,
Present, sir.
Ayushman, Sayam Jain,
Present, sir.
Prabhat Kumar,
Present, sir.
okay, Rutuja,
Yes, sir.
Swarn Shekhar,
Present, sir.
okay, Bansar,
Present, sir.
Ayush Singh, Ashmit Kumar Singh, Soumyadeep,
Present, sir.
Mohit Kumar,
Present, sir.
Shailesh,
Present, sir.
Piyush,
Present, sir.
Deepak,
Present,
Deepak Chaudhary, Ayush,
sir. Present. Present, sir.
okay, okay. Now those names which are not there in IT, I am naming them now. Adi Avasti, present है. Okay. Prakash,
sir.
Nikhil Mundra,
Yes, sir. Prakash Maji present, sir.
Sir, present, sir.
okay, Nikhil,
Sir, I'm Nikhil only. Nikhil Mundra. Present, sir.
okay. Anugya,
Present,
Anugya Antriksh, Naveen Raj, Naveen Raj is
Yes, sir.
absent.
मेरा हो गया. सर पहले हो गया. हेलो.
हो गया है तब ठीक है तो आपका नाम स्ट्राइक कर देते हैं यहाँ से. Okay, IT can leave.
Sir, my name is Prahas Kumar. You did